In this video, we're going to write the algorithm for the circular prime program. Before we begin, let us read through the question given. A circular prime is a prime number that remains prime under cyclic shift of its digits. When the leftmost digit is removed and replaced at the end of the remaining string of digits, the generated number is still prime. The process is repeated until the original number is reached again. A number is said to be prime if it only has two factors, 1 and itself. So an example of a circular prime number has been given. So 131, and let me show you this on the board. So given the number 131, this number is prime. Therefore, what we do is we take the last digit and we place it in front of the remaining digits, thereby giving us a new number which is 113. Even this number is prime. Therefore, what we do is we take the last digit and place it in front of the remaining digits. I shouldn't have written 1 here. Okay, and thereby giving us a new number that's 311, right? Now, how long should we do this? We should do this until we reach a number which is equal to the original number. So as this number is also prime, therefore we repeat the same task as we did before. We take this number, put it in front, and then we get a new number that's 1, 3, and 1. Because we have reached the original number, this is why we can safely say that 131 is a circular prime number. Now 131 was prime, so was 113, so was 311, and finally as we reach the original number, we can declare that it is a circular prime number. But take, for example, another number. Take, for example, the number 29. Now 29 is a prime number. So we move on to the next step. We take the last digit and we place it in front, and we get 92. Now we know that 92 is not prime. That is why we stop and we give the output that 29 is not a circular prime number. I hope the overall logic is clear. I hope the overall logic is clear. I'm going to keep them for the time being. Now, we have been asked to accept a positive number n and check whether it is a circular prime or not. The new numbers formed after shifting of digits should also be displayed. So here is an example with the number 197. So we display the first number, the second cycled number, the third cycled number, and finally, when we get a number which is equal to the first number, uh, I guess they misprinted. The first thing should have been 719. This should have been 719, and then it should have been 197. There's a misprint. No issues. We know the thing, right? So 197 is a circular prime number. Now, whenever you're trying to solve a problem of ISC in your terminal tests or in the actual board exam, you should keep one thing in your mind to cool yourself. All ISC programs, at least the questions, have the logic within it. They mention how you should do the thing and what you should do, right? So here they have told us with plenty of examples of how we should make the cyclic shifts and what we should do after each cyclic shift, right? So don't panic. Even if you cannot solve the first one, even if this does not click, move on to the second question, right? Don't panic. The all ISC is doing is testing whether you can take a recipe and write a product. That's it. That's all that they are asking. All right. Let's move on with the algorithm of this program. So I'm going to make a duplicate of this code. Let this be here. All right. So if you saw the first video in this series, then you know that the first step of every algorithm is start. So step 1, I'm going to write start. Then in the second step, what we do, the second step, we take the number as input from the user. Step 2, input number in num. Now, because at the very end, well, let's not write that here. No, no, let's not write that here. All right. Step 3. So we check whether this number is a prime number or not. If it is, we continue. Otherwise, we break. I'm going to write it with a new color. Check if num or is prime. Well, we don't need to write check if num is prime. We can just simply begin with if. If num is prime, go to the next step. Go to step 4. Else, go to step. Now I don't know at which step I'm going to write the output message, which is why I'm going to leave this part blank. Now, step 4. Moreover, do you notice something? I've written if num is prime. I haven't explained how I should test num is prime. So whenever you're solving a larger problem, you can assume that in your algorithm for such smaller subtasks that the user will know that what is prime and what is not, unless it's a thing, a completely different thing, a completely different term that the mathematics cannot describe, right? We know what a prime number is, therefore we can straight away write if num is prime, go to step 4. We need not define how we are checking num is prime, all right? So in step 4, what we do, we display num. Because we have to display every cyclic shifts, right? Display num. Step 5. Next, what we should do? Next, we should make the cyclic shift. So in cyclic shift, what exactly do we do? We take the last digit. In fact, I missed a step here. Well, I'll address that a little later. Take the last digit of num and place it in front of remaining digits. And store the new number in num. Whether you're going to use string to solve this or you're going to use some expression to do this need not be written in this sort of an algorithm, right? We just tell what we will do. How we will implement it is a part of the code. Now, in step 5, in step 6, how long should we continue? That is what we will check in step 6. If num, you see, here's a problem. We haven't stored the original number because for step 5, the number has already changed, right? So these are the kinds of errors that you're going to have while writing algorithms. This is the reason why I tell my students to write the algorithm in pencil, because sometimes they have to modify their algorithm. Sometimes, right? Like in this example, I needed to save this num in a separate variable so that I can compare the current number with the original number. Now I have the privilege of selecting the entire thing and then shifting it down. But if you write using a pen, you wouldn't have that privilege, right? Therefore, write your algorithm in pencil first. When you're satisfied with your algorithm, then write on top of the pencil algorithm with a pen, right? I don't know the exact words aren't coming to me right now. So the new step 3 is going to be this. Stored, or in fact, we don't need to write this. Original num equal to num. And we need to change all our step numbers. This is the reason why please write your algorithm in pencil first, and then such that you can change something later. 6, 7. Make sure your algorithm is not untidy. If it is, your marks are going to get deducted, right? All right, continuing. If num is not equal to original num, do you notice something? I did not write this operator between them. Why did I not do that? Because in some languages the not equal to is written as this. Therefore, that programmer who is reading through your algorithm might get confused. This is why write in plain simple English which can be understood by a layman. So if num is not equal to original number, that means we still can perform cyclic shifts. All right. So we go to step 4. All right. Now, else, if the number is equal to the original number, meaning after so many cyclic shifts and checking that all the cyclic shifts are prime, we have got back our original number. What does that mean? That means the number that was provided to me is a circular prime number. Hence, we display else display what was asked of us to display is a circular prime. Display original number is a circular prime. All right. Else display original num is a circular prime. And all right. Okay. Now, if the number is not prime, then what we should do? That is what we're going to write in step 8. Display. No, actually. You see, this is the thinking process that you will go through while writing the algorithm. I haven't prepared any material from before such that you get the real experience of how to write the algorithm. Else display original num is a circular prime, and we can end our program, right? And go to step. I don't know the step number as of yet, which would be the step number for end, so I'll leave a blank. All right. Step 8. So if the number is not a prime number, we will go to step 8 and we will display original number is not a circular prime. Then finally, the last step would be stop. And in step 7, if the original number is equal to the current number, then we display that original number is circular prime, and then we can go to step 9. because the program is finished. And that's it. This was the algorithm for circular prime. Let's go through this algorithm again. So we start, we input a number in num, and then we store the num in another variable called original num because it will be helpful to us later. Now, what do? First, we check if the number is prime. If the number is prime, then we go to step. I need to change this here because I changed the step numbers. See, this is why you must do your revisions properly. So if num is prime, go to step 5, display the number, else go to step 8. All right. So in step 5, if the number is prime, we go to step 5, we display the number, and then what do? We make the circular shift by taking the last digit of the number and placing it in front of the remaining digits and storing the new number in num. In step 7, we check whether we have performed all our cyclic shifts or not. So in step 7, we check if the number is not equal to the original number. If it is not equal, meaning there are more cyclic shifts that can be performed. Hence, we go to step 4. Else, we display that the original number is a circular prime, and we straight away go to step 9, which stops our program. Now, if at some point we find that a number is not prime, then we go to step 9, step 8, where we display that the number is not a circular prime. And then we finally stop. So I hope this you understood how you should write your algorithms. This will take a few tries and then you're going to get accustomed in with writing algorithms. All right. So see you in the next video. Bye for now.